Lesson number 2 for today is all about writing lines of best fit. Now, another word that we might use to talk about lines of best fit is a regression. Okay, we can write regressions for all types of equations that we'll study in this class, but specifically today we're writing linear regressions. Now, these linear regressions are ways for us to write equations of lines, but also to predict the future for real-world situations. So entering data into a table in Desmos or a TI-84 calculator can generate a line of best fit by producing or giving you a slope, an m, and a y-intercept, so that you can write y equals mx plus b equations. Going further though, the question, or I could, ask you to predict either an input, an x value, or an output, a y value, based on the context of the question. So we have to be able to read these questions to know if they gave us inputs or outputs when we're making our predictions. Some of you will be familiar with these steps to write a regression equation. I've heard that some of you used this last year. Okay, so you're going to add a table on Desmos. There's a little plus sign, and then choose table. Then you put in the entire table. You have to put the entire table in. Don't put just 2 or 3 points. I need the entire table there. Okay. There's a step in here I want you to press that's not listed. There's going to be a tiny little magnifying glass kind of to the little bottom left of your table. I want you to always click that magnifying glass because it's going to show you your data much better. And then last but not least, you type in this equation that I'm highlighting in red. Please notice that this is pretty much equation number 9, but we're going to call it fancy number 9. So number 9, but fancy. Okay, y1 squiggly line mx1 plus b. If you look on your keypad, the squiggly line is right here on the very end. Okay, it's next to, what is that? Like a sideways asterisk or accent mark. You got your tilde or your squiggly line up in the top corner of your, what's that called? Keyboard. Okay, so if we want to write equations of lines and make predictions, we're going to need this information. All right, example number 1 here. We're going to write a line of best fit and then make a prediction. It says, the table shows the mileage in X in thousands of miles. So this is not 22 miles, it's 22,000 miles. And the selling price is also in thousands of dollars, so not $16, it's $16,000. Actually read that part. Of several used automobiles. And that makes sense because it wouldn't cost you $16 to buy a vehicle. It might cost you $1,600 or $16,000. Now, based on the table, what is the best prediction of the price of an automobile with 6,000 miles? Okay, so your spidey senses should be tingling. First thing we need to do is write a line of best fit. So we're going to go to our Desmos, and we're going to add a table. Okay, I'm going to type in that entire table. Do you have to type the whole thing? Yes. You need to type the entire table in to your graph here. Both the inputs and the outputs. Make sure there are no typos, so give yourself a little second to check. And then we're going to press this magnifying glass. The magnifying glass is going to zoom fit my information so that I can see it on my screen. I don't have to move it because my face is in the way. But we have all of our data there on the screen where we can see it. It's chosen the best view for us to see that data. To write a line of best fit, I'm just going to use equation number 9, but fancy, which is y1, so just y and then 1, like I literally pressed 1 and it made it a subscript, squiggly line, mx1 plus b, the fancy version. At this point, we need the m and b here because that's going to be my slope and my y-intercept. I'm not really worried about rounding today, so we're just going to copy down that entire number for slope and the entire number for the y-intercept. So this would be the line of best fit, y equal to negative 0.183628 times x plus 19.7168. That's my equation for the line of best fit. Again, I'm not really worried about rounding, so whatever. But we need to make a prediction. It asks me, what is the best prediction of the price of an automobile with 6,000 miles? Now, if they told me I have 6,000 miles, did they give me an input or an output? Yeah, they gave me an input. They actually gave me the input of 6, because remember, we're measuring x in thousands of miles. So 6,000 miles is just 6. Okay, so let's make that prediction. If we have the value that x is equal to 6, that's a vertical line on this graph. And if you notice, I'm going to make mine a different color. I'm going to make it orange. If you notice, I now have my prediction line, my orange prediction line, crossing my red line of best fit here at 6, 18.615. So the best prediction for the price of an automobile with 6,000 miles is $18,615. $18,615,000. $18,615. That's what we can assume that this car would be worth. We've made a good prediction based on our data. So we're taking this cause and effect relationship, finding a way they're related to each other, and then predicting the future. Now, why did I put x equal to 6 and not y equal to 6? Yeah, x equal to 6 because they gave me 6,000 miles, and miles is literally labeled x. Okay, cool. Let's go to example 2. And because we're changing examples, I'm just going to go to Desmos and delete out everything because I don't need that anymore, and go home. Okay. The table shows the distance in miles Tom rode his bicycle on the time y in minutes of each ride. Based on the table, what is the best prediction for the time that a 20-mile ride will take? Okay, I have an input of distance and an output of time. I'm going to write my line of best fit, which means I'm going to Desmos. I'm going to add my table. And I'm going to copy down the entire table into Desmos, double checking that I don't have any sort of typos or mistypes, or I didn't skip any numbers. You have to put the whole thing. So pause and make sure you can get the whole thing in there. Okay, I'm going to press this zoom fit button again, and voila, I have seen my data. We use equation number 9, but fancy. y1 squiggly line mx1 plus b, and it's going to give me the m and the b. So my line of best fit here, my slope and my y-intercept, is y equal to 5.16327 times x plus minus 1.13605. Again, I don't really care about rounding. We're just writing the line of best fit. We'll talk about rounding later. But we need to make a prediction for this data. It asked me to make a prediction for the time that a 20-mile ride will take. So they gave me miles. Did they give me an input or an output? Miles is literally labeled on x, so they gave me a prediction. We want to know when x is equal to 20 what the y value is. We know the input, we want the output. So, okay, x equal to 20. Oh, typo. Now, some of you might have to zoom out for this one to find where the two lines cross, but if we see our prediction line crossing our line of best fit, we can see that our prediction for how long it's going to take this bike ride to last is going to be 102.129 minutes. That's a lot of biking. But that's our prediction for a 20-mile bike ride based on our current data. We have made predictions for the future. All right, let's look at the last examples 3 and 4. Let me delete my stuff out of Desmos because that's just good habit. Clear it all out. It says the table from example 1 shows the mileage in thousands of miles and the selling prices in thousands of dollars of several used automobiles. Based on the table, what is the best prediction of the mileage of an automobile that cost $15,500? Well, shoot, we already erased out all of the table there, but no worries, we can just write it all back. So take a second, pause the video, and I want you to get this table back into your Desmos. Okay, so I've got my table in there, and I already used the fancy equation number 9. Didn't ask me to write the equation here, just wants me to make a prediction. It says, what is the best prediction of the mileage given that it costs $15,500? So they gave me cost. Did they give me an input or an output? Check back at the table. Is price the input or the output? Yeah, price is the output. So they gave me that the output is $15,500. Okay, I can do that. So output is 15.5. Now, our best prediction of the mileage of an automobile where the line meets our line of best fit. So I don't know where it just cut off, but it cut me off, so I apologize for this, that it's all glitchy. But the best prediction here for the mileage of a car that costs $15,500 is that that car probably has 22,964 miles on it. We predicted the future based on our line of best fit. Again, they gave me an output. Output is y. So I look where that horizontal line y equals 15.5 crosses my line of best fit. Let's do the same thing for example 4 here. In example 4, it asks me to use the table in example 2. Oops, we already deleted it out, but no worries. We can put that table right back into our Desmos, making sure that we don't have any typos. It's so important to know how to type quickly and accurately. You're going to need to know how to do that for like the whole rest of your life. Might as well start learning now. And then we need to make a line of best fit. So y1 squiggly line mx1 plus b, the fancy version of number 9. And I have a typo. Fixed. So there's our data, which we've looked at before. But this time, we're asked to find the prediction for the distance given that we're riding the bike for 30 minutes. Knowing that we're riding the bike for 30 minutes, did they give me an input or an output? They gave me an output. They gave me that the output is 30 minutes. So I'm going to use that horizontal line, y equal to 30, to find out where it crosses my line of best fit. So we think if we're riding this bicycle for 30 minutes, we've probably gone 6.03 miles. So again, we can use the lines of best fit, the squiggly line version of equation number 9, to predict the future. This is the end of video number 2.